Everyone, welcome back to Structural Expert. Today we continue to analyze and design combined footing in Tekla Structural Designer Letter Current version 2022. Now let's start. Now let's click on the file, new to create new project. This combined footing, there are 4 columns about footing. And now let's define the dimension of the footing. Click on the model. You can create a construction of wall, or you can create the grid line first. Now let me create the grid line and click on it. And the length, that's the line style. You use the dash dot. Click niche. Click irregular. Tie it to. Now let me tie it 1.5, comma, and 1.5, comma, 1.5. Yes, how you can define irregular grid. Click on it. We do the same, 1.5. Or you can define 3 multiplied with 1.5. Yes, it's the same. Okay, if you want to change, you can come back to previous. And now let me change. Yes, I change it to the 1.5. Okay, that's correct. Now let me change it, 1 multiplied with 1.5. Okay, you can tie it 2 and 1.5. Yeah, it's the same. Okay, yes, 1.5 to 1.5. Now click on niche. Yes, click on niche. Click on finish. After that, we have to continue to create construction of walls. Click insert above. The spacing of the stem column or the height of stem column, tie it at 1.5 meter and click OK. Now let me click on the structure and the wall. Click on the base. Select on the model and select on. Now let's check slab on beam. Plus slab, we have to model the foundation. Click on the foundation, and the foundation you can create a pad strip, pie caps, and design pad. Now let me click on the minimum area. You can use the rectangular area. Now you have to define in the foundation. Click on the foundations, and you can click on the minimum area. Before you can create the minimum area, you have to create the object first. Create the pie foundation or create foundation. After that, you can create the slab area. Now we had to create the area because we has grid line. Now we need to create a real. Click on real. Overhang, click to 0. And the overall thickness, we change it to 500 millimeter. And cloud concrete, we keep it in default. And bearing, allowable bearing, we increase it to 150 kilonewton per square meter. And soil thickness, you have to correct it. Actually depend on the bearing capacity and the type of soil. You can check in my tutorial 3 how to calculate the actual soil thickness by using methods of both wall or method of basic. Now let's keep it in default. It's very important for the settlement and how you can verify it when you use the soil thickness. Now we can design based on the allowable soil bearing capacity. Now let's click 1, 2, 3, 4, 5, enter. Enter, yes. Let's click check on the 3D, yes. Come back, and now let's create the columns. Click on the materials, click on the column, yes, concrete column, click on columns. In the base level, we start from the base to the top level. The story one, the characteristic design as columns, rotation keep it 0, and the concrete class we also keep in default 32 megapascal. We use the auto design option, and the section, now let's change the section, create new section. Now I change it to 200, multiply with 200, click OK. For the rebar we keep it in default. Now let's click 1, 2, 3, 4. Okay, let's view on 3D. Yes, now we complete how to model the combined footing in Tekla Structural Designer. Now let's continue to loading. Click on load, click on load case. In the default of Tekla Structural Designer, there are several load cases, including save as, slash, disk, sequence, and import. Now let me keep in the default. Change the loads to the disk loads. Let input the disk loads. Okay, now let me keep in the level structural one, so you can model it directly. Loadings, and click on the point load. Okay, you see here how you can model a point load direct on the columns. Now let me change the magnitude of load to 50 kilonewton. Okay, 50 kilonewton. Let's get again. Or you can define it in the 2D loading. Now come back on the 3D. Let me escape. Click on point again. And the value is 50, is correct. And you can press S2. Now let me click. Okay, you have to check and change the position of load to 0. And you can change the position of load to the top. Okay, the top position is 1.5. And now let me change it. Now after complete the modeling or the combined footing with the stem column, now let's define the load. Change the load cast to the deload, and let's click on the point. Change the magnitude or load to 50, and now let's click, and change to the impulse load. Now let's change it to 30. Enter, click. Okay, come back to the load combination. Click on generate. Now we had to include for the GO combination according to the zero code equation 6.10 and EQU for the reinforcement design. Now let's click on next, and the combination based on the table equation 6.10 table A1.2b. Click on next and click on finish. Click OK, or you can create envelope. Now let me click on OK. Click on analyze. You can check for the setting, the default setting run in the first order analysis. Now let me click on the first order analysis, or you can use analyze or static. Now let me click on analyze or static. After complete run the first order analysis, you can click on the first order analysis, and you can check for the analysis result. Now let me right click on the review views, and you can directly check for the designs or the foundation. But before you can do that, you have to define and calculate the foundation. Yes, you have to design for the mesh. Now as the complete run analysis design, the result is pass. So let's check. Come back, use, and now let's check for the 2D. Yes, 2D, you can show the 2D, and now let me show the reaction. Okay, you see the reaction for the impulse load. Now you can change to the load combination. Now let me check for the load combination. Yes, the load combination 1, load combination 2. This is for the ultimate. This is for the load case. You can check in device shoe load case for the dead load, for the service, and for the impulse load. Now let me come back to the load combination. Yeah, now let me check for the load case, load group, load combination. We have to generate this again, and now let me generate it all. Just include the service load and GO combination. Click on finish. You can add other load combination manually. Now let me click on the add. I call it SLS, and click on SLS. We had to include the service and the load. Click on import and impulse load. Yes, now correct. Click on OK and let's run analysis again. And check for the load SLS. Yes, now you can check the result, the reaction at the base or the combined footing. The maximum is 16.8. Now let me click on design again. Click on foundation design made. Yes, complete. Pass. For the made foundation, you can click on the ratio. This is the ratio. The ratio is between 0 to 0.5. So this made foundation or combined foundation is working around 0 to 50%. It says it less than 1. It's over 1. This foundation is failure. And let's click on design. You have to complete design for the all C columns. Now click on design. Yes, fair. Now let's check why it's fair. Click on the views result. Now let me click on the 2D. I want to check about the 2D 1D elements and click on the Excel form. Yes, this is the Excel form. Is 114.5 kilonewton for the load combination 1 and load combination 2. Now let me check for the moment. You can click on the column, right click, open load analysis. Yeah, for the Excel and for the measure for the minor, you can check for the minor for the Excel load. Now let me close and again. Now let me click on the columns and you can create check why this column fair, ties, section, 3D analysis, the ratio fair, concrete cover, longitudinal rebar is okay. If fair at the series bar, yes, you can check for the series bar again. The tie diameter, the spacing is 125. and the maximum allow tile spacing is 120 because the required tile spacing is 120 is lower than tile spacing 125. So the Tekla Structural Designer not pass requirement, so we have to check it again. But this column is can resist the ultimate load, but you have to check for the shear reinforcement. Okay, for the combined footing is okay. Yeah, the design ratio is okay. Now you can check for the overalls. You can click on the 2D. Yeah, now you can check the deflection. The result, you can check for the total deflection. The long-term deflection is 8.8 9 millimeter, and the result type total, or you can check for the instantaneous. The instantaneous is 6.6, and for the differential between the maximum and the minimum is 0.9 millimeter, and for the total, and you can check for the final load events. Yes, you can show for the deflection and the testers utilization. Now let's check for the design slab. You can check for the overalls, check for the top, reinforcement. You can scroll the mouse over the foundation. You see the information foundation made, concrete class, and the top rebar 812, spacing 150, layer 2 812, 150, layer 1, bottom layer for the both direction. You can click on this foundation, click on check slash, it's okay, right click it again, click on check panel. Yeah, how you can check the analysis design result, the bottom reinforcement, and the area provide, area require. So area require based on the calculate or on the actual applied force. So this is the provide the area, and utilization is 0.2%. The bearing pressure is 0.256. It's okay. Reinforcement and the bearing capacity is okay. The allowable bearing capacity is 150 kilonewton per square meter, and the bearing capacity utilization ratio is only 0.2. So the max pressure is 38.4 kilonewton per square meter. click OK. Now let's click on the slab deflection review. You can see the deflection or the foundation. The maximum is 9.00 millimeter. Yes, it depends on the soil thickness you input in the first model. Now let me come back to the structural model, and the soil thickness very important to affect on the deflection of the soils or of the foundation. So before you can input it, actually you have to check in my 233 in YouTube channel how you can calculate based on both wall or based on the basic theory. And you can check for the total deflection, and you can check for the moment. Yes, see the edge top in the eight direction at the top and at the bottom. You can check here. Now let's change to the Y direction, Y bottom, and the bearing pressure. You see the bearing pressure. When you apply the load on the column, the load transfer from the column to the foundation. See the pressure, the maximum pressure is 38.4 kilonewton per square meter. Yes, the maximum pressure is at this area, and at this area is around 34.6. yes, at the edge. And you can check on the color gradient. You can also check for the MH, Vice, or you can check for the stress at the top and at the bottom of the foundation. You see the reinforcement required for the foundation. 8 bottom, 8 top, Y bottom, and Y top. So we show other the values, or you can show other pass and fail. So this result is pass. Now let me change at the top and at the bottom. Yes, it pass. Now let me change the value. Yes. How you can analyze the design combined footing in Tekla Structural Designer. I hope you enjoyed it. Tutorial 3. Let's share and let's share to other people about this channel, about this tutorial. I hope you enjoyed the tutorial 3. Thank you for your watching. Thank you. Now let me continue to the detailing. come back. Okay, click on the foundation, click on the, you can generate report for the member. Yes, this is the summary report for the member. The pressure, the maximum value is 38.4, and the allowable building capacity of soil is 150 kilotons per square meter. It's okay. This is for the reinforcement. Now let me close. Right click it again. Select, right click, escape. Select, right click, select, right click, yes. Now let me click on the draw. Click on the drawing. You can check for the columns, or let me click on drawing and general drawing, or you can check for the foundation reactions. Now let me click on general drawing. Before you click on the general drawing, click on the foundation plan, top plan, and change to the structural views, and come back to the draw. Click on drawing management, arrangement, slab made layout. You can add, click on OK. General arrangement, you can click on general arrangement, plan, section, elevation. The scale, now let me change to 1/25. Click OK. Yeah, this is the overall plan or the foundation. The slab thickness 500 and the column is 200 multiplied with 200. This is the overall plan. The top view, yes, scale 1/25. Now let me click on slab detailing. Click on OK. Yes, this is the total mass of the rebar A12 diameter of rebar, and the total length and the total mass. Scale is 1/100 in the default. You diameter rebar 12 and spacing 100 for both directions on the top and on the bottom of the foundation. Thank you for your watching. I hope you enjoyed the tutorial. Let's share each other to your friend and to other people about this video tutorial about this channel. Enjoy your weekend. Thank you.